Okay, so welcome to day 7, where we will review everything we've done really over the last week to get you ready for an assessment that will be tomorrow. So here we have just a couple of do now problems, one of each variety that we've been working on the last few weeks. If we look at the one on the left here, I notice that I have a root 3 and a root 3, so I can actually combine those terms. So my numerator stays the same of 4. I've got a coefficient of 2 and a coefficient of 1 here. So 1 root 3 plus these 2 over here gives me 3 root 3 is my denominator. Now, my radical is simplified. I can't do anything with that radical 3, but since it's in the denominator, I need to rationalize. So I'll multiply it by radical 3 in the denominator and radical 3 in the numerator. My new numerator is 4 radical 3. And my new denominator is this 3 times root 3 times root 3 is 3. So I get 9. 9. And that is it. As we look at the second one, what I notice that's different is that my radicals are different, so I can't combine them. So this is where we learned about conjugating the denominator, okay? So instead of multiplying by just root 5, which would get rid of the root 5, but over here would create root 3 times root 5, I need to multiply by root 5, the conjugate, plus root 3. Again, I'm looking at this entire denominator saying I can't simplify the root 5 or the root 3, and I can't combine them. So I need to multiply by, over here, root 5 plus root 3. Since I do it in the denominator, I got to do it in the numerator too. Okay. My new denominator, well, we have to FOIL this out. So root 5 times root 5 is 5. Then if I go outside, so this was my first, outside I'm going to get plus root 15. Inside, this root 3 times this root 5 is minus root 15. And then my last term, minus root 3 plus root 3 is going to be minus 3. So my new denominator, I'm going to scroll down here a little bit, is 5 plus root 15 minus root 15. Those will always cancel out. That's the whole reason we are conjugating. So we get 5 minus 3, which is obviously 2. So my new denominator is 2. But I got to go all the way back up here, and I need to distribute this. The 2 times the root 5 and the 2 times the root 3. Well, 2 times root 5, I'm going to write it over, actually I'll extend the page here. 2 times root 5 is 2 root 5. 2 times root 3 is plus 2 root 3, all over 2. Now this is an interesting one because notice that my coefficient here, and my denominator, I can simplify that. So root 2 over root 2 here cancel out, and I'm left with root 5. And the root 2 here, the number 2, coefficient of 2, and this 2 cancel out, and I'm left with root 5 plus root 3. Okay. So today I'm just going to do a couple of homework problems actually. So you'll see in the Schoology page, you'll see some problems, and I'm just going to do a couple for review after I do these quick review problems. So again, looking at this problem, I'm distributing. I've got this term times this term and this term times that term. So W times 5, my outside times outside gives me 5W on the outside, and 2 times 6 is 12, so root 12, minus 2W root 2. So again, I just distributed the W root 2 to the 5 root 6 and got this. 5W on the outside, root 12 inside. Then I went back and distributed the W root 2 over to the minus 2, and I got minus 2W root 2. And before I go on, I notice that root 12 can be simplified. I know root 12 is 2 root 3. We've done that a lot. It's 2 times 2 times 3, so 2 root 3. So I'm going to take this 2 times this 5, and I'm going to get 10 and w on the outside and just a root 3 minus 2w root 2. Notice everything after my coefficient. Here it's a w root 3. Here it's a w root 2, so I cannot combine those, so I'm finished. So my final answer would be 10 w root 3 minus 2 w root 2. Again, if you have questions, definitely send me an email, or you can re-watch it. It's the benefit, I guess, of these videos. Looking at our second example here, I noticed right away root 4 can be simplified, so do it. Square root of 4 is 2. So 2 times 2, this becomes 4 times 3, which is 12. So that's simplified. Over here, already simplified. So I just have negative 4 times root inside number times inside number is 6. So I have 12 minus 4 root 6, and that's done. This is a coefficient with no radical. This is a coefficient with a radical that's simplified, and so I can't combine them. Then lastly, looking at this last example here, again, I notice I've got a radical that can be simplified. So my new numerator is 5 minus 2, which is 3, and keep my same denominator. So that's just 5 minus 2 is 3, and my numerator and my denominator is root 5. Now, this denominator is simplified, the radical, but it's in the denominator, so I need to rationalize. Multiply by root 5, multiply by root 5. My new numerator is outside number 3, root 5. I get 3 root 5. And then my denominator, obviously rationalizing, just a reminder, radical times a radical. If it's the same, then the radical just goes away and I'm left with what's inside. So root 5 here times root 5 here gives me that 5. And so my final answer, 3 root 5 over 5. Okay. In the last few minutes of the video, I just want to do a couple of examples that are on the homework. We're not going to do this Kahoot, sorry, but I do want to do a couple of problems that are on homework practice number 7. And specifically, let's do a couple of the odd ones. Let's just look really quickly at number 1. So number 1, and you can write this down too, 2 root 5 plus root 36 minus root 5. I notice that this radical is simplified. So is that. This radical is not. Square root of 36 is 6. So let's rewrite it as 2 root 5 plus 6 minus a root 5. Now I notice I have a root 5 here and a root 5 here, so I can combine those. 2 of them minus 1 of them gives me 1 root 5. So 1 root 5 plus 6 would be number 1. Let's drop down to number 3. Actually, let's do number 4. And I will post, obviously, the answer to all of these. I just think sometimes it's useful to help you see somebody work them out. I've got 2 root 7 in parentheses times 3 root 5 plus 3 root 3 times 10 root 2. Okay? So outside number, I notice this radical is simplified. This radical is simplified. They're all simplified. This is simplified and this is simplified. So now I'm multiplying outside number times outside number, 2 times 3, 6. Inside number times inside number, 7 times 5 is 35. Then go over to this term, outside times outside, 3 times 10 is 30. Inside times inside, root 3 times root 2 is root 6. Root 35 is simplified. It's just 5 times 7. Root 6 is simplified. It's just 2 times 3. There's no pairs in there. So my final answer is 6 root 35 plus 30 root 6. And then let's drop down to, on the back side, let's do one example of, well, let's do a couple of examples. Let's do number 8. I've got a 3 root 10, so this is one where you're kind of simplifying the fraction over 5 root 6. So I noticed that my root 10 is simplified, root 6 is simplified. So I could also write it as outside and then put everything, a fraction on the inside, right? So when we say simplify the radicals, if we have a fraction inside the radical, we can simplify that too. Well, 10/6 I know is the same. If I divide top and bottom by 2, I'm going to get 5/3. So I could rewrite this as 3 over 5 times the square root of 5/3, which is 3 over 5 times root 5 over root 3, which is then 3 root 5 over 5 root 3. So I've done a little bit of work, but ultimately we just kind of went from this original down to here, really by just simplifying the inside numbers. I'll give myself a little more space. And so I notice root 5 is simplified, root 3 is simplified, and now I need to rationalize. So I'm going to multiply only by the radical in my denominator. My new numerator is 3 on the outside, root 15, because root 5 times root 3 gives me root 15. And my denominator, 5 times root 3 times root 3 is 15. Well, the root 3 times root 3 is 3. Times 5 is 15. Now notice in this example, my coefficients can be reduced. 3 over 15 is the same as 1 over 5 times root 15. So hopefully, again, you see what's going on here. These coefficients can be simplified. And now I've got that, which I could then just rewrite as root 15 over 5. Okay. Lastly, let's look at number 11. 11 is a good example of a conjugating one. This will be the last example. Again, these are on your homework, so hopefully this will help you do the homework. Root 3 over 2 plus root 5. I need to conjugate y because I have two terms, two terms. One of them is a radical. So if I just multiplied this term here by root 5 and distributed there and there, I would end up with 2 root 5 plus 5. And now I still have a radical term. So that's why multiplying just by root 5 doesn't work. I need to multiply by the conjugate. Whoa, jeez. Lost my thing here. So the conjugate again, oops, sorry, almost erased. The conjugate are my same terms, 2 and root 5. I just changed the sign. It was positive here, negative. If this positive over here was negative, then this negative over here would be positive. But this is how we have it. And since I do this on the denominator, obviously I have to do it on the numerator too. Always have to multiply by, this thing always has to be 1. Just finding an equivalent fraction. My new denominator, remember the shortcut is my first term, 2 times 2 is 4, minus the product of my last term, root 5 times root 5 is 5. Because the outside minus 2 root 5 and the inside plus 2 root 5 will always cancel out. So when I FOIL this, remember foiling this, I'm always going to get just the product of my first term and my last term. And that's negative 1. So 4 minus 5 is negative 1. That's my denominator. Now my numerator I need to distribute. Okay, so root 3 times 2 is 2 root 3. And root 3 times root 5 is minus root 15. Okay, so So my final answer is 2